Welcome to another unit of the ISM Exercise Set Statistics 2, this time with a unit on probability theory. The exercise we get reads as follows. Professor X commutes with the train between Wuppertal and Cologne. Here, delays occur on a regular basis. The probability of a train being delayed in the morning is 5%. Whereas the probability that a train is delayed in the evening is 80%. The probability that both trains, so meaning the morning and the evening trains, are delayed is 4.3%. That's more or less the background story. First task then is, what is the probability that the morning or the evening train is delayed? Second, assuming the morning train already has been delayed, what is the probability that the evening train will be delayed as well? And finally, C, you see that the evening train arrives delayed. What is the probability that the morning train has been delayed as well? Well, let's work through those three parts step by step. So let's start with the first one. Here we want to have morning train and evening train being delayed, or both. So here we have as an information the probabilities that the morning train is delayed, that the evening train is delayed, and that both of them are delayed. So we can just use the addition theorem to get that either of them is delayed. This here is just probability that the morning train is delayed plus the probability that the evening train is delayed minus that both are delayed. If we insert our values here, we get as a result 80.7%. So there's an 80.7% chance that either the morning train or the evening train or both of them will be delayed. This concludes part 1. Then for part 2, the question has been that under the assumption that the morning train is delayed, what is the chance that the evening train will be delayed as well? So here we need a conditional probability, and to calculate the conditional probability, we already have what we need. We have the probability that the evening train is delayed, we have the probability that the morning train is delayed, and we have the probability that both of them are delayed. So we can use here the formula for the conditional probability, giving us here the conditional probability as probability that both are delayed divided by that the morning train is delayed. Meaning here we have 0.043 divided by 0.05, giving us here a chance of 86% that if the morning train is delayed, the evening train will be delayed as well. Okay, so far for the second part. Let's start then with the third one. The third one, we want to have the exact opposite as in B. So here we're more or less switching the condition. And whenever we do something like this is a good indicator that we're going to use the theorem of Bayes. That's what we're going to do here. For this, first off, we need to have the condition in the other place, so the probability with the switched two events, and we need the probability of each of the two events happening. So here we are giving probability of morning train being delayed, probability of evening train being delayed, and the probability that under the assumption that the morning train is delayed, the evening train will be delayed as well. Then we can just look up the formula for the theorem of Bayes, which here would look as follows. And we can insert the values from the given part, looking as follows. And they result in a value of 0.0538 or 5.38%. So there's a chance of 5.38% that if the evening train is delayed, the morning train has been delayed as well. Well, and this already concludes the third and final part of this exercise. And I hope you enjoyed listening to it. If you're looking for more exercises, feel free to visit the rest of the exercise set or take a look at the corresponding playlist. I say goodbye and see you next time.